there, I'm Cindy Davis, Content Director of AV Technology, and I'm thrilled to have with me today Shane Roma, Technical Product Manager of dvLED Commercial Displays at ViewSonic. We're going to answer some questions that are in a lot of minds about direct view LED, how the displays work, pixel pitch, cost, and use cases. So let's get to it. So Shane, what exactly is direct view LED and why has it become such an important display technology?
Yeah, great question. Thank you so much for having me. Excited to be here. So, direct view LED is it's actually been around for a long time. It is when imagine the LEDs, and I think we all know what an individual maybe LED is, but the LEDs are actually acting as the pixel. So if we think of a traditional display, it may be LED backlit, but then there's an LCD that it's going through before you're looking at the image, and that's going to be like when you think of a TV or a commercial display. Direct view LED is a little different. So direct view LED from an application standpoint allows us to get very large images in a seamless way. And it's called direct view LEDs because there is no liquid crystal display. You are looking directly at the LEDs, directly viewing the LEDs. In practice, what it is it's going to be a series of what's called cabinets. And those cabinets they're going to have receiving boards in their power, things like that. And then you tile them with LED tiles. The benefit to that is you can put many cabinets together to build very big video walls. Not all video walls are direct view LED, but all direct view are video walls. And that just means we're creating multiple different displays for one giant image. Furthermore than that, there are processing and things that have to happen in terms of having that image, blowing up that image, making sure it looks good and things like that. So all the parts and pieces go together between the cabinets, the tiles, the processor, the mounts, power, everything comes together to create that. But essentially, it's a way to get very large images without needing to go with like a liquid crystal display.
So with that, you don't have, because you traditionally, a few years back, you might see video walls that have thin bezels, but with the direct view LED, you don't have any bezels. Is that correct?
That is absolutely correct. So we've all seen it. Whether it's in airports or bars, places like that, malls, where you've got a video wall where it's a series of what looks like TVs put together with really thick bezels. And for the longest time, that was really the most effective way to create those large images, and it was the most accessible way to do that. And so it's great for what it is, but there are a lot of drawbacks to it. The number one is what you just brought up. You can see the bezels. It interferes with the image, and if you're trying to do a seamless experience, you're not going to get it. Some other things beyond just the bezels, though, is they're very heavy. They consume a lot of power. Each one of those is going to have their own power, need their own plug. And then they're very difficult to maintain. If one of those units were to go down, it's very difficult to take one off and replace it, and then they're not color calibrated correctly. And so what can happen is they can look really good when they're installed, but just a couple years later, they look really bad. They're doing more harm than good. Direct view LED is completely seamless. So it's going to look like one large display. And then the modular nature, I mentioned that it uses cabinets and tiles. The benefit to that is that it becomes a modular system. And so if a pixel were to go out, an LED were to go out, or you ran into issues, you can hot swap those tiles and maintain that same image calibration with calibrated spares. And it's much easier to do and easier to maintain and lasts longer. So your total cost of ownership is going to be smaller than those traditional LCD video walls.
Nice. So without getting into the weeds too much, how do they actually work?
Yeah, so I kind of hit on it a little in terms of what direct view LED is, but essentially it's you've got these cabinets, and you can almost think of the cabinets as displays, and they have a receiving card that's bringing in the image. They've got power, and then you tile them. And so each one, let's say for a 27-inch cabinet, if you will, which is going to be the diagonal of it. So if we think of a 27-inch computer monitor, it's a 27-inch cabinet. It's going to be the same size. And then typically it's going to be 4 to 8 tiles that you would put on there. So it's all very modular, and then you stack those together. And so you may hear it as an array. And so one of the most common sizes for direct view LED is 136 inches. That is a 5 by 5 array. So there's 5 columns, there's 5 rows, 25 total cabinets. But you can put those very close together. And so when you tile them, it all looks like it's one large image. And then to go beyond that, that's when you need a video processor or a controller of some sort. Because each one is acting as its own display, you need something that's going to be able to split the image so that it shows as one big image. And so that's where you get into a controller or a video processor that's going to make that happen. There's kind of two different ways you can do that. There's a traditional one where it's actually like a third party controller that you have to configure. And then there's all-in-one, which is where it's included with the video wall and everything's kind of pre-configured on it. And then, of course, the power. There's going to be you'll need a power supply that's making all that magic happen. Typically, the cabinets are going to be connected via like category rated cable for the video, and then the power is just going to be that power cable.
All right. I actually want to bring up some of these specifics a little bit later, like all in one. But one of the questions that comes up often is pixel pitch. Now, people assume you need the finest pixel pitch for everything, but that's not quite true. So, it kind of go in a little bit to what pixel pitch means and what applications you might need different pixel pitches for.
Yeah, and this is probably one of the most common questions. So I brought up that you've got the cabinets and then you've got the tiles, the LED tiles, which are acting as the pixels. So if we go back to our example of 136 inch at where we've got 5 by 5, so we've got all the tiles there. If this were a 1.5 millimeter pixel pitch, what that is saying is that for that LED, there's 1.5 millimeter distance between the center of that LED to the center of the next LED. It's a little confusing though. So the best way to think about it is that is the distance, but it's also the density of it. And so that means that for that same size tile, 1.5 millimeter pixel pitch is going to define how many of those LEDs are on there. And so for 136 inch, 1.5 millimeter pixel pitch, it's always going to be defined in millimeters. That's going to give you a 1920 by 1080 resolution. So there's 1,920 LEDs horizontally, 1,080 vertically. Right? And so that's the density of it. If, though, we were to go to a 0.7 millimeter pixel pitch, we're tightening it. The tighter the pixel pitch, now there's less distance between the pixels in that same space. Right. And so now it's much denser. We've now quadrupled the number of pixels and now we're at a 4K resolution. So that's kind of the relationship between pixel pitch and resolution. The tighter the pixel pitch, the more pixels are going to be on that tile because there's less space in between them. The higher the pixel pitch, the less pixels are going to be on that tile. They're going to be spaced farther apart. So that's kind of the quick and dirty of it. How that relates to in practice is at the fixed sizes, like I was mentioning, it's going to define your resolution. But what's more important is it really depends on the viewing distance. The pixel pitch and how high or low you need to go is going to depend on the viewing distance of that application. So you brought up, there's kind of this thought, the lower the pixel pitch, the better. Because the thought is the more pixels, the better it's going to look. But in DirectView LED in practice, that doesn't really apply because DirectView LEDs are so large. A lot of times the audience is going to be much farther away. When talking about DirectView LED and, there's indoor and outdoor applications, but if you go to like a stadium, all of that is going to be DirectView LED at this point. Arenas, stadiums, things like that. The pixel pitch is actually going to be really high. If you were to get up close to these, the pixel pitches are really far away. And on some older ones, red, green, and blue is actually separated. But when you're sitting in the stand, it looks incredible. And then as you get closer is when you need to tighten that pixel pitch. So the farther away you are, the audience is going to be away from it. The higher the pixel pitch, the closer you are, then the tighter the pixel pitch. The reason why you just wouldn't automatically go to a tighter pixel pitch is going to be cost. So there's going to be cost and then also power requirements. The more pixels you have, the more power it's going to need to then consume. The higher the requirements are going to be for the processor in order to process it. And then it's more expensive. So then when you do the higher pixel pitches, that's maybe a better fit for that application. You're going to save cost, but also save on power consumption, the complexities of the processors, things like that.
So what's the range that we're talking about? Because I know pixel pitches have been coming down. So what are the ranges that we're talking about?
Yeah, so for the indoor application, so there's kind of two different applications. There's going to be the indoor and then the outdoor. Outdoor applications tend to have really high pixel pitches, things 4 millimeter and then goes much higher than that. Once we go indoor, we go to, you might hear it referenced as fine pixel pitch. That's going to be like 2.5 millimeter and lower. For the indoor application. The general rule of thumb when you want to calculate it, and different people say different things, but it's going to be around 10x of the pixel pitch, but converted to feet. What I mean by that is at a 1.5 millimeter pixel pitch, about 15 feet is the optimal viewing distance. At a 1.2, 12 feet, 0.7, 7 feet, that's kind of the general rule of thumb. So if we think of, let's just say, a gymnasium application, you're going to be much farther away from that. You're going to be at least 25 feet away. So at that point, you're good with a 2.5 millimeter pixel pitch, and that image is going to look amazing. If you're an executive boardroom, though, and you're going to be much closer, you're 6, 7 feet away from it, that's when we want to go really tight and maybe go with that 0.7. But if you did that 0.7 in a gym application, you're going to be spending way too much money, and you're not going to notice. It's going to look exactly the same to the viewer because they're going to be so far away. There's no benefit to that type of pixel pitch. But generally for indoor, you're looking at 2.5 at the high and then 0.7 at the low. And then keep in mind, higher pixel pitch means actually less pixels, lower resolution. Lower pixel pitch or tighter pixel pitch means more pixels, higher resolution.
Perfect. So pro integrators should consider specifying pixel pitch. When they're specifying dvLED solution,
Yeah.
pixel pitch is one of the things. Viewing distance. So, what are some of the other things that integrators should consider when specifying the dvLED solution?
Fantastic question. And it's really not that much different than any other application in the sense that you really want to look at, hey, what is the user looking to accomplish in this space? What's the content going to be? Who's going to be creating that content? And that's obviously the viewing distance. That's really going to drive a lot of how it's specified. And then also complexities of the install and things like that. So there's kind of two different things: is the user application, but then also the install environment. So for the user application, it's going to be, hey, how are you looking to use this? So I go back to the boardroom example. Is this going in a boardroom where people are going to be plugging in their laptop? It's going to be standard resolutions. It's going to be standard aspect ratios. That's going to be a much simpler design. You're going to want 16 by 9. You're going to probably want 1080p or 4K. What's the budget, right? We can talk about optimal viewing distances, but there's a lot of cases where, hey, the budget is not going to allow that, but hey, it's going to be 1080p. It's still going to look great, kind of thing. Versus I go back to that gymnasium or auditorium application, we're going to be much farther away. Maybe we don't need a standard 16 by 9 aspect ratio. Or if we think like a lobby or something like that, we're going to be making custom content. Let's do that. I think one of the pitfalls that integrators run into and end users run into is, hey, I have this wall. I want to use all the available space. Well, great. Who doesn't? But that's going to create now a really wonky resolution, really wonky aspect ratio. Who's making content for that? Right? Have we thought about that? Are we going to be going outside of 16 by 9 or 1080p or 4K content? And that custom content generation oftentimes will be more expensive than the video wall itself. So thinking about those things ahead of time and making sure the end user's thinking about those things ahead of time is really key, just to understand the application. And that's going to drive the pixel pitch, the aspect ratio, the resolutions, and things like that. Then there's also the install environment, which is going to be, hey, where is this going to be mounted? Is it going to be on drywall? Is it going to be on concrete or brick? How high up is it going to be? Because that goes into, okay, do we need to rent lifts? Do we need to reinforce the wall? Like if it's drywall, do we need to reinforce the wall? Because walls are almost never flat. If it's brick, concrete, do we need to do special mounting considerations? And then power. Is there power to the location? 9 times out of 10, it's probably not going to have the specific power that direct-view LED needs. A lot of direct views become a lot more efficient power-wise, so you can get away with 20 amp, but a lot of systems, as you get bigger, require 30 amp or sometimes multiple 30 amp drops. So considering that, how are we going to get there? And then also making sure I mentioned gymnasium applications or some of these other applications. Are there fire alarm systems there? Are there sprinklers there right now? Are there other things that you can't get around that's going to impact it? So it's very much a measure twice, cut once sort of things. The more you do on that front end, both in the application and that's going to give the user the experience that they're looking for and expectation wise, but then also installation so that there's no surprises when you're on site and jobs are getting delayed and it gets a lot more expensive.
Great. So it sounds like, actually kind of wondering, has dvLED changed the actual workflow for Pro AV integrators?
Yeah, so it's a good question. I think a lot of it is similar. Like it's a similar workflow in the sense that um, it's a similar workflow, as in you want to understand the application, things like that. But there's probably going to be a little bit more prep. It's going to be more complicated than just hanging a display on the wall, right? And so going into what is the wall structure, can it support this weight? I didn't bring that up either. Weight requirements. We these are heavy. If they're really big, they're going to be a little heavier. Things like that. So I would say it doesn't fundamentally change it, but they do need to be much more aware than maybe on just a typical display or something like that. And then depending on which direction they go, whether it's an all-in-one or whether it's a traditional direct view LED, then it also changes, okay, how much more prep work do we need to do? How much time do we need to spend on site, commissioning it, programming it, things like that? It would be much more than like a traditional display type system. So just making sure more keep in mind, because if you do get it wrong, then it can be much more expensive than, just mounting a display on the wall.
You had mentioned that because of the flexibility, you can create highly customized visual environments. So that's really different, and new and uh, offering for integrators. How, and you mentioned you've got content there, but the customized visual environments has to be really exciting and a new avenue for integrators.
Absolutely. So that's it opens up a lot more opportunities that were restricted to maybe specialized groups in terms of giving very unique experiences. So direct view opens those up now to these to integrators where maybe otherwise they weren't, because you needed a really highly specialized video engineering department. You needed really highly specialized install, things like that. Direct view LED allows these experiences to happen in a much more accessible way, especially over the past couple of years. Direct view LED technology has increased a ton, reliability has increased a ton, manufacturer support has increased a ton. So now the integrators have more options than ever to provide these like innovative experiences, and they're not trapped inside the confines of, hey, these are the displays you can use, or these are the projectors you can use. If we even think about things that technology offers, so if you're in an environment where a lot of ambient light, the only way to get a big image was a projector, but now we have a conflict, of course, because ambient light's going to conflict. You need super high brightness or whatever it is. Whereas direct view LED doesn't have those challenges because the ambient light is not an issue in the same way it was with projectors. So it just opens up a lot more opportunities, and the customizability allows them to kind of put it together almost like Legos to fit that space. Again, keep in mind that, hey, we need the content and we need to make all the other things that go along with it, but they have that option now available if they want it.
Yeah, and I've seen some of the installations and they're just stunning. So, all right, all this leads to it's really the assumption that dvLED is hugely expensive. So, how is that true? I know prices have come down, but how should they think about cost?
Yeah, good question. So a couple things. I mentioned the technology's come a long way, but that also means the costs have come down considerably just in the past couple of years. So direct view LED has never been more accessible than it is right now. And the direction is that it's continuing to go there. We're kind of flattening out, but we've come a long way. But it's not just that upfront cost. It's also going to be, the user experience that we talked about in terms of having that seamless image. It's also about, I talk about the ambient light when we're looking at versus projectors and not having to worry about that. It's also just the lifespan of the product. I mentioned total cost of ownership. It's much easier once they're up, they're kind of set it and forget it. And then they're much easier to maintain. And so if, let's say, you've got dead pixels or something goes wrong, you can swap out those tiles most of the time they're going to be hot swappable. Versus if you have a projector system and that projector goes out, that's a much more complex swap. And if you look at, let's just say, a projector application, you've got, when you start looking at total overall costs, especially for the larger ones, you start getting into tension screens, high brightness projectors, all the mounting and everything that goes along with it. And then now you're replacing lamps. You're probably going to have to replace that screen at some point. There's a lot more maintenance that's time consuming than also cost wise versus direct view. Like I mentioned, once you put it up, they tend to last. So looking at it holistically of not just here's what it's going to cost us at the initial install, but where's this system going to be in 3 to 5 years? And then you can start seeing a lot more of the value versus just that upfront cost. But it's surprisingly affordable relative to where it was a couple of years ago, for sure.
Yeah, that's great news. So you mentioned earlier all-in-one LED. What do you mean by that?
Yeah, so I mentioned there was the traditional and the all-in-one. So the traditional, just as a refresher, is kind of it almost like it's you're building your own PC. And if you've built a PC, it's hey, you've got your motherboard, but there's a certain slot for the processor that you have to use. So it's like, yeah, you're building it yourself, but the parts and components are kind of you're picking which ones, but you're doing everything yourself, and it's fun to do. But you have to make sure you're doing the right things. Everything's going to be compatible for you to get a working system. And traditional direct view LED is very similar to that, where the processor is being purchased separate from the cabinets and the tiles. And then you have to map it out. You have to tell it, okay, here's how the cabinets are lined up. You have to calibrate it. You can get really customizable with it, but it can also be really time consuming. All in one is all of that is now included. And so all in one means that the controller, the power, everything is actually pre-done. And so when you get the unit, all of that's already going to be set up. You're not buying a separate third-party processor. You're not spending time calibrating everything. It's much more plug and play. It's much more similar to an experience you would expect from a traditional display, where it's just going to work versus requiring a ton of setup and customizability. So almost think of it as the difference of a traditional direct view LED is like building your own computer, and all in one is if you're like buying like a Dell or you're buying something that's already pre-done. The OS is already on it. All the components are there. You just have to, power it on.
So what sizes are we talking about?
Yeah, so I can talk about ViewSonic, specifically and how we approach it with all in one. With ViewSonic, all of our products are all in one, and so we have two different types. So we have pre-configured, which are set sizes that are going to be 16 by 9, and they're going to be at either 1080p or 4K resolutions. And then we have a configurable that's still going to be all in one. So for the pre-configured, it's going to be 108 inch, 136, 163 and then even up into the 200s at 217 and 231 inches. So a really big range. 136 is going to be some of the most common, but we have a 108 because there are 110 inch like LCDs, but they're so big a lot of times they don't fit in elevators or it's difficult to bring them up the stairs. So the 108 is like an alternative to that to get into those spaces that maybe can't take the full 136. And then once you start getting into the 200s, gymnasiums, lecture halls, things like that, and those are off the shelf. We actually stock those here. That's the other advantage is that you can stock them and just get them off the shelf versus all made to order. For the configurable ones, whatever size you want. We can make those as small or big as you need to be. So you can get up to 300, 400 inches, and we can go much crazier with it. With ViewSonic, they're still going to be all in one. So they're still pretty easy. But then also, of course, you can go traditional and you can do that as well. But yeah, there's no real size limitations to all in one, at least in the way that we do it.
Nice. So um, there's really a lot of applications for the all-in-ones.
Absolutely, yeah. I mean, the most common ones are going to be boardrooms, classrooms, lobbies, multi-purpose spaces, gymnasiums, cafetoriums, et cetera, et cetera. Those are, I would say, 80 to 90% of the applications are going to be those pre-configured, those off-the-shelf ones that at the standard resolution, standard aspect ratios. That's going to be the vast majority of the applications. But then once you get into the configurable, it opens it up to pretty much every application. We've done museums, we've done control rooms, We've still done higher education. We've done corporate. If you want different aspect ratios, hospitality, it really opens up the doors to so many other applications.
Okay, so let's dig a little deeper into the use cases. And ViewSonic offers several dvLED product families. We've got the LDM, the LDC, the LDS, the LDE series. So let's break those down and fit them into different deployment scenarios, and use cases. So let's start off with the LDM.
Sure. We love our acronyms here. We really do. So I will do, before I get into that, I'm going to do a little bit of a pitch to say that we also offer resources here where if you are curious, you can reach out to us, let us know what you're working with, and we can help recommend the right one so you don't have to memorize everything.
Absolutely.
And we kind of organize things maybe in a good, better, best. So I'll kind of lay it out that way. We have a mobile series. So this is one that's on a cart. It's foldable. So it comes pre-configured, pre-installed, everything, plug and play. You order it, ships in a flight case, take it out of the flight case, plug it in. There's no installation. That's our LDS series. So anytime you see the LDS, you're going to know it's that mobile one. So if you don't want a permanent installer, you want to be able to move it around, fits in standard elevators, that's going to be the LDS series. Once we go to installed products where that LDM lives, we actually have 3 series. And think of it as kind of like a good, better, best. We actually have a series called the LDE series. That's going to be the best entry point into direct view LED. It is so simple. We took the all-in-one to the next level. And so instead of having a separate all-in-one controller and power supply, the all-in-one controller is built into the cabinets. So there's no extra wiring. Everything's built in, plug and play, put up the cabinets, tile them, plug in the power, plug in an HDMI, and you're good to go. It's at a very cost-effective price point as well. So if you're looking for the most cost-effective but the simplest direct view LED, that's going to be the LDE series. Once we move up, that's where the LDM that you mentioned comes in. That's going to be kind of the middle of the road. What it does add is it adds some more advanced features. So it's going to add the ability to connect to Wi-Fi and Bluetooth. Over-the-air updates can be managed by ViewSonic Manager. It also has some video processing in it in the terms of you can do like split screen or quad view or things like that. So if you want multiple images on there at the same time, instead of getting a separate video wall processor, that's all going to be built in. And then at the highest level is going to be the LDP series. That's going to be 4K. So that is pretty unique to us in the sense that you can get 4K beautiful images, but still be in that all-in-one simplicity. And that's where you're going to see those really tight pixel pitches. I'll do a quick mention too that all of our series are going to have some sort of protective coating on it. So our focus is going to be in public-facing environments. I can tell you the first thing that anyone is ever going to do when they see a direct view LED is they're going to touch it. They're going to point at it. Yeah, exactly. And so we didn't really get into the actual LED technology, but I'll do a quick thing on that where there's SMD technology, which is the most common type, which is how the LEDs are packaged on the board. They use wiring and things like that to mount on the board. There's SMD, and then there's chip on board, which is instead of using wires and things like that, it's actually the LEDs are mounted directly to the board. You might also hear it called flip chip. That's going to be more expensive, but due tighter pixel pitches, SMD is going to be much more mature product line or much more mature LED technology, more cost effective, but it's not going to be as durable. So then what we did is we use glue on board technology, which is a coating that goes over the SMDs. And so all of our products are either glue on board. So like LDE, LDS, LDM are all glue on board. And so they're IP rated and also impact rated. So when I do my demos, I'm punching them and knocking on them, things like that. They can withstand a lot of abuse. And then chip on board inherently has that impact protection as well. So all of our series are meant to be in heavily used environments. And so those pre-configured I went through talking about, being in schools or being in corporations, they're meant to withstand that. And then the final series is, the final series is going to be the LDC series. That's going to be the configurable series. That's where we can break away from standard 16:9. We can break away from standard resolutions, and we can really customize those systems. It's still all in one, but what we're doing, it's going to be made to order. But in the factory, we are actually loading all the configurations onto it. And so when you get the unit, it's already mapped, it's already calibrated, it's already ready to go. So you still retain the simplicity of all in one, but you get that extra customizability for it.
Boy, the whole dvLED has come such a long way in just past couple of years. It's amazing.
Yeah, absolutely. So yeah, the tech increases are crazy. Every Infocom, there's new advances. So kind of sneak peek, I mentioned SMD and I mentioned COB or chip on board. We're about to see some newer technologies that are coming in, such as MIP, which is going to take that to the next level as well. So we're keep seeing the technology increasing, but it's still very accessible. So yeah, it's never been a better time to be in the dvLED business for sure.
Yeah, great. So I'm going to ask you to go a little bit further. You know, where do you see dvLED technology evolving in the next few years? I know a few years is a lifetime these days, but you know, what do you see coming up?
Yeah, so I see a proliferation of direct ULED beyond it being a specialized product and starting to become the standard. So when we start looking at conference room rollouts, we look at classroom rollouts, lecture halls. Right now, projector is still, in many ways, the standard, especially in education. In the next couple of years, I see that moving more towards direct ULED as the initial costs come down, and as they start to understand the total cost of ownership, those will start to be much more direct ULED heavy. They'll continue to be simpler, more accessible. So I see a lot more integrators who previously were not in direct ULED because of the specialization required are going to be doing much more direct ULED, and a lot of end users who may not have considered it before are also going to be jumping into it a lot more just because it's now going to be the best fit for their application. From a technology standpoint, it's going to be kind of like what that LTE has started, where it's going to continue to get simpler and more accessible. The barrier to entry continues to get lower, just from both a cost and technology standpoint. So I see that trend continuing, and then the image quality is going to keep going up. So as we see some of these technologies like chip on board and then MIP coming online, we're going to see the image quality really increase and allow us to get to really tight pixel pitches, great color reproduction, contrast ratios, things like that. So there's going to be less and less trade-offs, and it's going to make it so direct view LED is going to be now become the standard and the assumption, not the specialized point you go to once you've gone beyond, projector or something like that.
Nice, exciting times for the whole visual display market. It's really cool to see where it's all going.
Yeah, absolutely.
So Shane, to wrap up, where and how should someone get in touch with you and ViewSonic to get more information? Because we covered such a small amount, and people definitely want to get some more information.
Yeah, great question. So, ViewSonic, we're here as partners to both our Pro AV integrator partners as well as our end user partners. So, there's a few different ways you can get a hold of us. Our website is one of the best starting points. It's going to have a lot of great information. We do an FAQ where we do break things down. We also have collateral on there, obviously the product pages, explanations, videos, things like that. But you can also reach out to your rep there, or if you already know who your ViewSonic rep is, reach out to them, give us a call. All of us are US based, so I'm here in our Brea headquarters here in Southern California. All of our tech support is out here. All of our field engineers are out here. So also feel free to call into us. We'll answer any questions. And then visit us at trade shows. We're going to be at InfoComm this year, so we'll have a booth with plenty of this direct LED. Feel free to stop by and say hello. Happy to walk you through all of it.
Great. Well, thanks, Shane. Great conversation. Can't wait to see you at InfoComm.
Yeah, see you there.